So as we know, today's agenda is Apache Hive we have. So Hive, what is that? Let me discuss about this first thing. So Hive is meant for manage the data in the form of table. So whatever the data we are getting from the clients, we have to create a tables and we have to load the data in the table. So that is known as tabular data. As you are aware of the RDBMS, first when we are discussing or when we are just fetching the data, before that we have to create a table as per the schema, and then we just insert the commands to write the query and all these things. So here also we have to manage the data in the form of tables here. So what is that? Let me write some definition about Apache Hive. Hive is one of the component of Hadoop, which is data warehouse. Which is data warehouse. So what is data warehouse? As we have discussed on the demo class, what is data warehouse as well. So data warehouse is like there is a big hardware. On the top of the big hardware, a huge volume of hardware. On the top of that, we have to dump or install one of the RDBMS tools. Anyone like Oracle, Teradata, Netezza, EDB to anyone RDBMS tools, that becomes a data warehouse. That capacity up to TBs only. Data warehouse. So kind of system. Okay. It is exclusively meant for processing part of data only. So as I told you earlier, Hive is meant for processing purpose only. So whatever the data we have created here, tables we have created here, so that data which we are loading in the table, we have to analyze that as per the requirements and summarization of data. So one moment, let me open a paint here. So assume like this is our Hive. Okay, these are Hive. So we have written here Hive, and this is our one of the component is known as HDFS, Hadoop Distributed File System. And after completion of that HDFS, there is a map reduce. Okay, come into picture. So I will tell you what is that. Let me write it first. Map reduce. So what is that? So see, the data which we are getting, the data which we are getting from the HDFS only, because the client's data first we have to import into HDFS. Okay, so it is like you can say data storage here. So whatever the data we have, we can store into HDFS, and after the HDFS, we have to process or from the HDFS only with the help of one of the tools known as Hive. What is this thing MapReduce? So as we know, MapReduce is the core components of processing purpose in Hadoop. Okay, so whatever the jobs we are triggering in Hive, whatever the jobs like select a, as we know in Hive we are just writing the queries here like it select update, no, update here also, but I will tell you how update and insert and delete these type of commands whatever we are doing, or we are just analyzing the data with the help of query, how that job triggered and how the job internally it breaks into the map reduce, because map reduce is the core components of processing purpose. So it is the processing thing we can say. Processing. Okay. So it is made for processing. So there is an internal structure like how the Hive works and say there is a Hive on the top of HDFS. Okay. So on the top of HDFS there is a Hive. It gets the data from the HDFS only, and after writing the queries, whatever the that queries which we are triggering from the Hive on the Hive console or Hive files, there is a .html file will be there. So I will show you these things as well. So that job will be converted into MapReduce only internally. Okay, so let me go back. These are overall about the Hive. So there is a note point. Just remember, just remind this. Okay, even though we are providing SQL SQL kinds of queries, right? SQL kind of queries we are providing here in Hive, like select, insert, update, delete, like that. During the processing, each and every Hive query will be converted into map reduce job. So whatever the query we are triggering here, it will convert into MapReduce jobs only. So as we have discussed earlier in the diagram. So it's all about the Hive we have seen. So now let's discuss about the meta store. That is the second topics in agenda. What is the meta store in Hive? So first understand what is meta store, then we'll go ahead with Hive. What is how it will be useful in Hive. So meta store is a internal database of Hive, okay, which is primarily, you can say, which is primarily responsible for storing metadata information of tables. So you are aware about the metadata. What is metadata? So data about data. That is metadata is all about data about data. So meta store is the internal database of Hive, which is primarily responsible for storing the metadata. So like in Hive, we are creating any tables with the help of some schema, some delimiter should be there. So we will see about that, how to create the tables in Hive later. First thing, if we create any tables in Hive, what about that meta store? Like what is that table type? What about its columns, schema definitions? What about its partition key? What about its column name? So this kind of information is stored into this meta store. So that is known as internal database. So now coming, whenever we install the Hive, there is a Derby database by default there. Okay, so whenever we install the Hive on the top of HDFS in the Hadoop ecosystem, by default Derby database should be there, but it is mainly used for single nodes of cluster. It's work on the single node cluster, but not for the multi-node cluster. So what happened? Because in the real time we are using the real time multi-node cluster. So for multi-node cluster, there should be external database, or means we can say meta store for storing the metadata. So what is that? It may be RDBMS. It should be RDBMS only. So it may be like MySQL, it may be Oracle, it may be Teradata, etc. Many are there. You can use anyone. So whatever the I shared with you that things like Cloudera distribution. In that we are using the MySQL meta store in Hive. So I will show you how we can check what is the meta store we are using for the external meta store. So we'll check that things as well. These are all about the meta stores only. So now coming to different types of tables. As we know, in Hive we are creating the table, we are loading the data, and we are analyzing. So there should be some types of tables should be there. So what is that? So first is the, we can say, default table, or it's also known as managed table, or it is also known as internal table. So these three names we can call anyone. Okay, if someone says default table or managed table, internal table, both are same, all are same. Second table is known as external table. So we will see what is that, what is external table, what is the default table. So we'll discuss about these things in brief, okay, later. So first you should know, whenever we are creating the tables in Hive without any keywords, what keywords I will tell you, what keywords I will tell you. So what were the keywords we are using there? Without using any keywords, that table is known as default table. But in external, one of the keywords we are using here, that is known as external keywords we are using here. Okay, so whenever we use external keywords, it creates the external table. But why, when, and how we use these two types of table? Like someone say, okay, so there's the two types of tables. So when I have to use the internal table, when I have to use the managed external table, so what is the reason behind that? What is the benefit of using these two tables? Also, we will discuss here. One of the agenda is difference between internal and external. In that, we will see these things. So let me show you. Okay, so these are all about the tables only. So now coming to the Hive data types. Okay, so
Quick question.
yeah,
Okay, if Hive is a data warehouse, right?
yes,
If you
yes.
consider it as a it's not data warehouse but similar to data warehouse. If it is a data warehouse, for an example, we will not able to change the data in the data warehouse. This is just so too static.
Yeah, you are talking about the changing the data, like over a modification of data, right?
Right.
Okay, so there is a concept known as transactional table. So I will let you know how we can modify the data, how we can delete the data
Okay.
records from the table. So we will discuss about these things later. Okay, so these are not here. So we can mention here for you, we can mention here one of the table known as transactional table. Okay,
Okay.
we will discuss how we can use this transactional table in Hive. Okay, how it is possible. So we'll see that
Hmm.
as well. Okay, so let me discuss about the Hive data types.
Okay.
So as you know, every language or every tools right now we have discussed about the Apache Pig and MapReduce has its own data types. So what about Hive? It also has its own data types. It's supportable. Teeny int. It is very less integers we have, so we can use a teeny int, a small int. Okay, and we can say int, big int. So these kind of data types for the integers only. Now coming to text, we are using string here and boolean for true and false. We can use boolean, okay, and we can use double as well, and we can use floats. Whatever the data types we are using in the RDBMS, so same data types we are using here. Instead of varchar, we are using here string. So that is the main difference here, and rest is same here. So time stamp also there. Okay, time stamp also here. For the data types here there. So this is the all data types which we are going to use in Hive. Okay, when we are creating the table, so we will use at the time these data types there. So now coming to okay, so let me go ahead with first default table or external table or managed table. So what is that and how to create this table? We'll discuss here. Okay. So first questions we have. So whenever we are creating table in Hive without any kinds of requirement, that table is known as internal table or managed table. We can say. So what is the syntax? Syntax for managed table. We can say. So there's a create table. If you want to use this thing, if not exist, that should be fine because it's a clause to avoid the runtime error. Okay, you have to give the table name here, and there should be some schema definitions here. So what, as per your data, you have to define the schema here. And if you are dealing, because we are dealing with files data from which are coming from HDFS, so that data should be in any format. It should be CSV, it should be JSON format. So like that, it should be delimited in different formats. It should be delimited in pipeline or comma. So for that table data we have to process, there is a concept, or we can say there is a way we can use this delimited. Okay, so we'll discuss these things later. First, we have to write these things. Fields, okay, terminated by, okay, here delimiter should be here. And coming to lines, terminated by, so lines terminated by, also here delimiter should be here. Whatever delimiter you have there, you have to write there. Stored as file type. So what is the file type here? So we will discuss about text file, avro, orc, RC, etc. Many files are there which is supportable by Hive. Okay, so by default it is text file, which if we do not mention anything here is stored as, so by default it understand we have to store the data as a text file only if we have not mentioned this is stored as. Okay, so this is the way we can create the manage tables here. So now coming to how to load data. Okay, after creation of the table we have to load the data into manage tables. So what is the command for that to loading of that data? So there is a command known as load data local. If you are dealing with local file system, your data is in local file system for the development purpose, you have to use local keywords here. You have to use whatever I'm using here, local. If your data is in HDFS, Hadoop distributed file system, you don't have to use the local keywords here. You have to give load data in path only. So now I'm going to local only because whatever data we have, I'm going to store as a from the LFS only. Okay, we'll see about the HDFS as well. You have to give the path local file system and into which table you are going to store the data. So this is the way it's for, write it here, local file system. The data input data coming from local file system. You can write it here, input data from local file system. Okay, if we can say paste it here, we have to remove this local from here and input data coming from HDFS, not from the local. So this is the two way we can deal with the load data into manage table. Okay, so we have discussed about the manage table. Now coming to the external table. Okay, so you cannot.
Hello.
Yeah, hello.
Could you please share your screen?
Yeah, the screen is not here.
Okay, okay. So now it's already there, right? Yeah. You can able to see my screen.
Yeah.
Okay.
Yeah. No. Yes.
Okay, fine. So coming to the external table. So there is a the syntax for the creating of the external table is same, create. But I told you with the help of when we are going to create the external table, you have to use one of the keyword known as create external table. If not exist, you have to give table name here, and you have to give the schema definitions here, and same as it is, we can copy and paste it from here. Okay, same as it is. So only the thing is we are using external keywords for creating the external table. So why we are going ahead with external table and with the managed table, so we'll discuss in the difference between that table, and we'll see the practical as well. So what is the difference between that? So that is fine. So for the loading of the data into external table, there is no difference between these things. The command is same for the internal and external, both for the loading of the data. Instead of this, you have to write here external. So both will be same here. When you are dealing with the external table, the loading command is same. When you are dealing with the local file system or HDFS file system, so we have to use local for the local file system. You have to use the HDFS. So you have to remove the local keywords from here. So for these two tables, everything is okay till now. We have seen the how to create a table. So this is the syntax, how to load the data, this is the syntax. And for the external also we have seen these things. So now coming back the difference. Okay, before that we have talked about some architecture related things of the meta store. What is the architecture? Means how the meta store works internally. So let me go ahead with the pen and I will write a diagram there, create a diagram. Okay. New. Yeah. So assume I am working on Hive. So Hive console is like that, and I'm just reading select star from tab table. Okay. So there is a one table. I have given this table name. Okay, these are our tables. So what happened when I trigger this command from Hive, it will go ahead one of the configuration file, like each and every ETL tools, external ETL tools, it has one of the configuration files here. Okay, so that configuration file, okay, that configuration file is known as con hive-site.xml. This is the configuration file. So what is that file? So in that file, all the configuration related to Hive, like which external meta store we are using there, what's the username, what is the password, what is the driver we are using there, it is ODBC, it is JDBC, this kind of information it will store there. So like it will validate like what is the meta store you are using there from that Hive, the hyphen.xml. After validations, it will come back to, okay, after getting this, I know it's I'm using MySQL. Okay, so it come back to MySQL hyphen connector. One of the jar is there. So that jar, what is the responsibility for that jar? There is a meta store there. Okay, there's like this is a meta store we have. So what happened there? When I go ahead with Metastore, it this connector or jar tries to connect, means it is like interface which will connect my Hive to Metastore, because these are the two different tools which we are going to connect to each other for fetching the data from that table, because Metastore contains the metadata information from that tables for that tables. So what happened in Metastore? That Metastore contains the like metadata in terms of table name, table schema, partition, key, we can say, and columns name, we can say. So this kind of information it is stored in the meta store. So what happened when I'm giving like table name is tab, so it will search in the meta. So is there any table is there? Okay, tab is here. So it will search like that, which is schema is okay for that. Okay, fine. Is there any partition key? What about the column name? It will search like that. It will check everything's validated from there. And after validations, where the data is stored, okay, the data is stored on the SDFS. As you know, SDFS is a core component for storing the data into the Hadoop cluster. So it stores the data into SDFS in warehouse path by default. User Hive warehouse. Whenever we are not giving any paths while creation of the table, we are not giving any path there when I have to load the data in Hive. So by default, this is the path by default, this warehouse. In that directory, the table should be created, and in that table, we are getting the data. So I will show you when the practical is going on after this uh, two or three topics. So you will understand the internal flow, what is happening there. So after validation of these things, if everything is okay, so it will come back to HDFS warehouse. It will fetch the data and it will come back to Hive from. It will show the data like in tabular format, rows and columns. So this is the main internal architecture, how the metastore internally works. Like whenever I give the selection from tab, I in 2 or 3 seconds I can get the data. But in 2 or 3 seconds, what is happening internally? This is the main scenario which is happening internally. So this is the architecture of the metastore. So let me
Okay, I have another question.
Yeah,
Is it managed table or external table?
for both.
For both.
Yeah.
Okay, where the where the external table metadata is stored on localized tables, or like if it's external table in Oracle,
Yeah, so
then
actually, whenever you are using on the cluster, like Hadoop cluster you are using, so what meta store you are using, like it is a Oracle or MySQL. So on the clusters only it will be there. Okay, so like if you are using MySQL, so in MySQL, but the meta store metadata information will be stored there only.
okay, got it. Thank you.
Okay, so let me go back to the agenda. So here we have discussed about the meta store. Difference, okay, internally with internally architecture. So now come back to why Hive is schema on read, not a schema on write. So you know about schema. Schema means like we have a data in terms of ID, like let me tell you, ID, name, location. Okay, so whatever the we have given these three things, and we have some data as per the ID, name, and location. So that ID, name, and location will become a schema, and ID with integer. Suppose zero is integer, name is string, and location should be also a string here. Okay, so a string. So whatever we are giving these three things, it's known as schema. Okay, so it's known as schema. So as we know, RDBMS, RDBMS, RDBMS is schema on right. Schema on the right. How? Let me explain first thing. So, like in RDBMS, I am creating a table. Like take an example, MySQL. I have created a table as per the schema information. Create table. Let me write it here. Create table. Table name. Like table name I'm giving here tab 1, and I can give it schema here. Like take an example. This is the same schema which we are going to use. Okay. So I am giving here same schema. Instead of string you can give varchar there. Okay, so just string you can give varchar in the MySQL, it will work there. So what happened, and give the enter command, it will execute and it will create a tab 1 table there in my MySQL. But when you are inserting data, like insert into tab 1, and you have give values there. Okay, so whenever you are inserting the data, so it will, like I am given, like in ID is 1, name is Shabazz, and location is Hyderabad, HYD, like that, and try to give, select and enter. So it will show like that one row is affected there. But the same thing I am giving like this, uh, instead of tab 2, tab 1 should be here, and instead of this I'm giving, it is not been single quotes. I'm trying to just run this command, trying to run this command the MySQL. So what happened? It will just check the data types. Okay, ID, it's in string, integer. Okay, it's an integer. What is the name? Name is should be in string or varchar. So that string should be in double quotes or single quotes, but there is no quotes. It will accept like integers or begin like that. It is not a string. So at that time you got like error there, error like data type errors like that you will got in the MySQL. So that's why I'm saying it is on schema on the right. It will check while writing the data into the tables. It will check the schema at that time only. That's why our DBMS is schema on the right. Now coming back to Hive. So I'm using the same example here. I'm using the same example here. I have created a tab table 1 there. Same things. I have the schema there. I am giving the thing is like that. Okay, that should be fine. It will, one row is affected, you will get the result like 1 rows affected. Okay, while you have run this command as well, you cannot get any error there. It will say like 1 rows affected. Okay, so like that it will give the result like that. But why? Because as we know, HDFS is the backbone of Hive, first thing, and there is no restriction to accept data in HDFS. You understand my point? There is no restrictions to accept data in HDFS. Whatever the data we are getting, like any kinds of data, it's a dummy data as well. There is no meanings of that data. It will accept it. Whatever the data is like that. So it will accept it in the HDFS. That's why there is no schema on the right. But when I give on the Hive console, select start from tab 1, what happened there? Then it will match the tabular, because as per the internal structure, if you will go back to the meta store, I have given select start from tab 1. It will check all these things, come back to meta store, check the schema here on the meta store while running the reading the data for accessing the data. At that time it will check the schema there. So what happened, instead of first row it will show clearly like 1 Shabazz, let me write it there, 1 Shabazz and HYD. But if you come back to the second rows, it will show like that. Okay, let me like that. It should be two here, and B, and instead of Hyderabad, I'm giving like Bangalore BNC. Okay, so I have given two name. The name schema is incorrect here because name is not in integer or string. So instead of name, you will get null value, and you can get BNG there because as per the schema, it will check column wise schema. If the column schema is not matching there, it will put the null value there instead of getting throwing the error. So this is why it is on schema on read. Hive is a schema on read instead of write. So RDB is schema on write. Hive is a schema on read. There is no restrictions while writing the data in Hive. So hopefully you understood this concept, like why Hive is schema on read. So someone asks like why I'm getting the data as a null records while putting the data. So you have to say like that. Check your schema first. What is the schema you have mentioned in the tables, and what type of data you are dealing with. First, the reason is like that. Second is check your delimiter first. What type of delimiter you have to put in the files, input files, and what delimiter you are just mentioning in the tables. So this is the second reason for getting the null records there in the Hive tables. So this is the way we will see accordingly when we are doing practically. So you will be aware of these things. Okay. So let me go ahead with now coming to the main points. Internal external table. So the main difference for these two tables is for internal table I'm saying internal table. When we drop tables, then it will drop the meta data as well as data from HDFS. First thing, let me write the external table. When we drop the table, then it will drop meta store, sorry, meta, not meta store, metadata only, not the data from HDFS. So why? So this is the way, means when I create the table as an internal table, and if we drop table name, so what happened? The table will be dropped from the meta store. Means meta store means the table we cannot able to access the table in future. Okay, so that things has been deleted permanently. But as well as the data which is the data is loaded in that table, which is stored in the HDFS path. That data also deleted from the HDFS as well. But in external, the table's metadata only is deleted, not the data from the HDFS. Why? Let me go ahead with a real-time example. Like when I am dealing with the Hive ETL tools, okay. So what happened there? When I have a hierarchical we can say jobs. Hierarchical jobs means multi applications are there, which which happen like I'm analyzing the data in Hive, and after that I don't want to use that table in future. I know there is no use of that table in future. So what I will do, I just go ahead and drop that table. Okay, I just go ahead and drop the table. So if it is an external table, so what happened, the data should be there. Why? Because if I know some other application team or some other team like visualization team, Tableau team will be there, who is using this data for their visualization purpose. So at that time we can say like that, we can go ahead with the external table if there is a hierarchical team accessing the same data. Like I have a data in the Hive as well, and some other team also may in accept or access the data for their own analysis. At that time we have to use the external table. But I know there is a only life cycle of Hive only. There is no other teams. There is no other application. There is no other external teams are there to access that data. I am the only responsible for that. There is no other team. So at that time you can go ahead with the internal table, because if you drop the table, there should not be any impact with the other teams. But in Hive, if you drop the table and you know there is a other teams as well using the data, and you created a table like internal table. So what happened? It will delete the data from the SDFS as well. It will impact to the other team because they are not able to access the data in future. So that's the main reason you have to take the decision accordingly as per the requirement. When I have to use the external table, when I have to use the internal table. So hopefully you have done with the internal external table difference. This is the main difference only. So if you have any queries here, let me know. I will go ahead. Okay, so let me go ahead. Okay, that should be fine till here. So let me go ahead with some practicals. Okay, till we have discussed about the theoretical things. So I'm just going with practical. So let me share this screen first. So this is our Cloudera. This is the Cloudera which we are using right now, 5.13.0. So Mandy, what version you are using in your Cloudera CDH?
I'm using Cloud 5.7 or 13 kind of thing.
Okay, okay. So it's okay. It will work there, no problem. Okay. So let me go ahead with Hive console. When I go ahead with Hive console, you have to give Hive there, Hive and then enter. Like in Pig, when I am dealing with the Pig as a SDFS model cluster mode, I have given the Pig PIG and enter. It will come to the grunt shell. So like here, you have to give the Hive there only. So it will come. It will take some time. In meanwhile, just give Control Shift P for open the new terminal, new tab. You have to give sudo hyphen I. What happens if you give like this, it will not ask the root password. If you don't know the root password and you want to go to the root, you can work on this command sudo hyphen I. Okay, so without asking the password, you come to the root. The root. So you can just go ahead and check JPS. So JPS means you are checking the one of the command for checking the all the services running in the cloud. So all the services are running there. Okay, that should be fine. So now I am coming to the Hive console here. Okay, so now go ahead with this. One moment. Yeah. So yeah. So show database first. I have these databases right now. So I'm creating a new database for this batch. Create database. Database name like batch 2. Okay. I'm creating a database here. Okay. Now database created. So show database. So there is a batch 2. So now I'm using these databases. So batch 2 you can give here. Okay. So now I'm inside the batch 2. So now I have to show any tables is there. Right now there is no tables as I know. So we have to create the table. So before that, I'm just going to SU hyphen for and you can see is there any files which we have cd desktops. Hopefully there is a file in partition.log. There is some files there. Okay, so cat bucketing. I have this data. Okay, so nano bucketing here. Mm, yeah, so this is the data we have. Okay, this is our employee ID. This is the organization name where the employee works. This is the employee salary and this is the employee location. So we have for a schema here and all the fields in terms of columns, we can say it is delimited with pipeline. Okay, this is the pipeline is a delimiter there and we'll see. Okay, so now I'm going to create a tables, create table if not exist. Okay, yeah, exist. Table name we have to give like it's a managed man underscore tab. And what is the schema here? I'm just going to load this data into the Hive table. So as per the data, you have to create the table and schema definition as per the data only. So here is the employee ID first, emp ID we can say. It should be in integer, that should be fine. There is a C name, company name is the second one, it should be in string. And third one is salary. We can get salary is in big int. Okay, salary is also in the big integer because it doesn't come the integers. Okay, so now coming to the location, so it's also a string. Okay, so this is the schema we have for that data which we are going to load. So enter row format delimited, because we are loading the data in the files, which are storing the data in files. So that's why we are delimiter here like pipeline. Somewhat you are getting the, instead of pipeline you will get comma, instead of comma you can get colon. So these kinds of delimiter you will get there. So delimited fields, as I told you, fields terminated by, how the field is terminated by, here you can able to see there pipeline, you have to give pipeline there. Lines terminated by, so it's new line because after completion of this it becomes a new line, right? So the new line is a new record, so like that it will store the data in the tables, and we are going to store as a text file here. So I'm using the by default text file there. You'll see. So now it's taking 1.149 seconds to create this table. So what kind of table we have created here? Anyone? What kind of table we have created here? So it's a managed table because we have not used any external keywords here. It's a by default managed table only. If you want to check what kind of table it is, so there is a command known as describe formatted table name. You have to give man underscore tab. Okay, so now coming back to up, you can able to see the schema informations like employee ID, CNAME, salary, locations. This is the batch 2, that is the database. These are user Cloudera, which has been created by the Cloudera user. And this is the locations where the table has been created. So I will check, show you. And this is the table type. Table type is managed table. Okay, so and what about this? The fields they delimited it by pipeline and this thing. So what is the helpful of this command? What is the help of this command? So let me show you one thing. Whenever you are a new joining in the any project of Hadoop development, ETL tools developer as ETL developer, and someone told like there is a table, you have to load the data. So you know the data, you are aware about the data. Data is delimited with anywhere, so you can able to see the data. But the internal architecture of this table, like any tables which you have to load on that table, you don't know the internal architecture of that table, like how, what is that, if it is external table, it is the internal table first thing, where is, what is the location for that table, and how the table is delimited with, how the lines terminated with, is there any serialization, is so many information we have the questions. So with the help of this command, or okay, with the help of this command, you can able to see all these things. Whatever you have the dot, okay, it's a managed table first question. This is the database, and this is the location where this table is stores the data, and it is delimited with pipeline. So everything is okay. Okay, so I have dealt with the pipelines data. So here is the pipelines data. Okay, that should be fine. So this is the describe of the table. So now I'm going to load the data. So load data local in path. Because why I'm giving local here, because this data which we are going to load, it is in LFS, not the HDFS. Okay, so copy this path and put into this here, paste it there. And with because in that path there are two files, so you have to give the file name. Okay, so copy the file name bucketing and give slash here, and you have to paste it there into, sorry, table. What is the table name there? Man underscore tab. So you are going to load in that table only that data. So let me enter. The data is loading the data into table batch 2 the database. That man is there. Okay. So there's the one files only which we have loaded, and total size is about 643. So let me give the select star from man underscore tab. So now you can able to see the data is stored as per the, okay, so that is fine. All the data 15 rows we have. So if you want to validate, how many rows here, WC hyphen L bucketing. So you can also see the number of records is 15 here with bucketing files data. And you can also see here number of fetched records is 15 here. So it means I got the whole data. There is no data lost here. So if you are dealing with millions of records from one of the data sets from the file, so at that time it may be possible you will lost some data. So for the checking purpose, you have to use this command wc-l there. Understand? Okay. So let me go back. It's all about the internal table or management, you can say. So now coming back to the external table, we have to create external table if not exists, and we have give the ext underscore tab to the external table. I'm using the same data I'm using. Okay, so we'll see the difference only. What is the difference between that? I'm using the same schema here. Okay, so emp id, which should be integer, cname, which should be string, and there is a salary, which should be in the big int only, and there's a location, it should be in the string. Okay, so not row format delimited here, fields terminated by, as you know, fields terminated by this, lines also terminated by new line here, and we can give it stored as a text file. Yeah, so now the table has been created within 0.212 seconds. So now let me check show tables here. Okay, sorry, there's spell mistake here. Show tables. So able to see the one of the managed table has been created, which we have seen. Now coming to the external table, you have to describe formatted ext underscore tab. So now you can able to see the table tab is external. Okay, it is the you warehouse path where the table has been created. Here is the batch directory. So this is the thing, same thing. Okay. So now let me go ahead with load the data. Load data local, because we are dealing with the local paths here only. So let me copy this. Okay, so what is the path for this? So this is the path which we are dealing with, right? Copy and paste it here, and you have to give the file name, because the file name which we are dealing with bucketing only. So copy the file name and paste it here into table ext underscore tab. Let me enter. So it's loading the data. Data has been loaded. So now give me the select star from ext underscore tab. So now the data has been, it hasn't showed there. So we have seen the external table and managed table. So now coming back to the overview of this, like how to see in the GUI. If you want to check like how the data, like this file system, we have seen SDFS, DFS, or listing the directory from the SDFS only. So you can able to see from the these things, GUI, graphical user interface. So first you have to go to this Cloudera, that's first screen, go to Hadoop, go to SDFS name node. Okay, so in that you have to come to below. At the end, you have to see here very transparent legacy should be written here, legacy, and browse the file system. And after that, you have to go to, as I told you, whenever I have not defined any locations, it creates the directory of database or tables in the user, in Hive, in warehouse, and inside that there is a batch 2 DB is there. Inside that we have created two tables. One is the man tab and one is external direct tab. So whatever the table we have created in SDFS, it's like a directory, as you can see here. So we are going to head a external tab. Inside that we have loaded this data only. So it's like a files which whatever the data we are loading in the Hive, it's creating the files there in that tables only. So whenever I click on that, it will create, you can able to see the data here. So it's fine. So I can able to see the external table data. I can able to see the bucketing managed table data. So now I am just going ahead to drop both tables. what my requirement is, I'm just going ahead to drop both tables. Like first I'm going to drop the man tab, drop table man underscore tab. So as I told you, as an internal table, as an internal table, we have when we have to delete the data table. So by default, the data should be deleted from the warehouse directory. So let me go ahead and check. Okay. So in bash 2, there is no directory here. So the data also lost here. And if we give select star from man underscore tab, so whatever you are getting here, table not found because that table has been lost. So what the meta store has deleted, metadata has been deleted first, then the data also from the HTTP has been deleted. So it's all by internal table, not coming back to the external table. Still we have the tables here, ext. So now going to drop table ext underscore tab. So the ext tab has been deleted, that table. So going ahead with meta store ext underscore tab. So we can see table not found ext underscore tab, but the table schema, all information has been deleted. But what about these things like data? The data is still there in the HDFS, as I told you, because there are multiple applications or teams which are already connected with that table data, and they can able to some analyzation purpose, some doing some analyzing or some summarization of data there. So it will not impact the business. That's why we are dealing with external table whenever we are in a hierarchy job, hierarchy process. So that's why this is the main reason. And we can take the decision accordingly what kind of table we have to create there. If this is the only Hive life cycle, we have to use the internal table. If there is a hierarchical process, we have to use the external table. So till we have discussed about the internal and external tables there. So let me go back to the agenda and whatever the, stop the recording first.